So the section 4.5 is called modeling. Thanks. With exponential and logarithmic functions. Alright, so there's a lot of different cases in which you would need exponential or logarithmic functions. The ones we're going to look at today are going to be population growth, radioactive decay, which is like population decreasing, Newton's law of cooling, and if we get to it, pH scale, magnitude of earthquakes, and sound intensity, how loud something is. Okay, with population growth, I'm going to write out an equation you're going to use. Population decay is very similar, so I'm going to, or radioactive decay is very similar, so I'm going to write them next to each other.
Each have different formulas for everything else?
Yes, but these two have like almost the same formula, so I'm going to write them both next to each other. So, population growth, you can think of as N of t equals n sub 0 e to the RT. N of t is the end population. N sub 0, anything sub 0 is like initial. So initial population. E is a number that we already know. R is rate, and you want that in a decimal. T is time. And they usually tell you what it's going to be, like in hours or years or days. Okay? This should remind you of PERT. We used PERT when you compounded something continuously to figure out like how much money you had. It was A equals P e to the RT. It's the same formula, only we have N of t and N of 0, but they sort of represent the same thing. N of t being what you get at the end, and N sub 0 meaning what you get in the beginning. So it's similar to PERT.
I can't say I remember PERT.
Okay, radioactive decay, you write out as this. M of t equals m sub 0 e to the negative RT. So again, it's almost the same thing, only instead of a positive exponent, you get a negative exponent because you're going down, you're increasing, or decreasing instead of increasing. So m of t is, again, the end amount. M sub 0, anytime you see a sub 0, you should think of as initial or start amount. E is a number, R is a rate, you want it in decimals. And T is time. And again, it'll tell you how it's to be measured. The only other thing is they also give you another little formula to make things a little easier. It's called, well, in radioactive decay, we're talking about radioactive materials. They all have half-life, so how long it takes them to get to half of what they are. The half-life is H. So you also have the formula R equals ln of 2 over h. It makes life a little bit easier for you. H being the half-life.